The number of people who survived the Titanic based on class and gender is provided in the following table. So I have female, male, first, second, and third class, assuming a gender dichotomy there. But if we had more than two genders, I might have more than two columns here, depending on how you're going to break that down. So the first question is asking the probability of female. That's out of everyone. So I'm looking at the total of females, 306, out of the overall total of 446. It says round to three decimals, so I'm going to type this number into my calculator. 306 divided by 446. And I'm getting approximately 0.686 for that first value. Second question here. What is the probability that the survivor was in second class? Again, this is out of everyone. So I'm taking the total of second class, 117, and I'm going to divide this by the overall total of 446. 117 divided by 446 gives me a percentage of 26.2%, or as a decimal, 0.262. What is the probability that a survivor was a female given? Okay, this is a given style question. Given they were in second class. So I'm told they were in second class. Whatever information you are given determines your denominator. In this case, it's out of second, so it's going to be all the information in that row that has a total of 117. And for this, I'm looking at the proportion that are female. I'm only allowed to use the numbers in that second row. In this case, it looks like there are 93 individuals that are female out of the 117 that were in second class. So if I divide those values, 93 divided by 117, I end up getting a proportion of 0.795 or so. And I'm going to make a quick aside here because I'm noticing that the proportion of females in general is 68.6%, but the proportion of females in second class is higher. It's 79.5%. Whenever the probability of A is equal to the probability of A given B is equal to the probability of A given not B, we would say the events are independent. This means the ratios are the same. If the ratios are not the same, and that was a wild spelling for the word independent, sorry about that. If the ratios are not the same, we say they're dependent. In this case, the probability of female, 68.6, is different than the probability of females in second class. So there is a relationship. So in particular, this tells me that class and gender are dependent. These numbers would have to be the same in order to be independent. In particular, I'm much more likely to find someone that was female in second class than I am to find someone that's female overall. There's a higher proportion of females in second class than the overall rate. They are dependent. There is a difference in the ratios. Okay, I just want to make a quick aside about that. I have the probability of female, the probability of second class, the probability of female given second class. Let's calculate some more probabilities here. Part D. What is the probability that a survivor was female and in second class? Using the word and. When I see the word and, I'm finding the spot where they meet in the table. Female meets second class at that number 93. So that's 93 out of the overall total, 446. The only time you're going to see that denominator change is when you're dealing with a conditional probability. 93 out of 446, so I'll type that in a calculator. Gives me a percentage of 20.9% or so. Part E. What is the probability that a survivor was female or? So it's giving me a given style question, an and style question, and now an or style question. Or gives me more. So or says take all the spots in the table that are female and add all the spots for second class. This is going to be out of the overall total of 446. So I'm going to take the female spots of 133, 93, and 80. I'm going to add all those numbers up. And I'm going to add all the spots for second class as well. I already have the 93 included, so I just need to make sure that I'm also including that 24. So for an or style question, or gives you more options. Add everything that includes the first criteria, all the female spots of the table, and then add any remaining spots for the second variable. In this case, the second variable being second class. Let's start with the numerator. So I have 133 plus 93 plus 80. Oops. Plus 24. And I'm going to divide this by the overall total of 446. And this gives me approximately 0.740. That 99 rounds up to a 40. Let's try typing in these results into my open math and answer any remaining questions that they might have. So starting with the proportion of female. That probability was 686. Probability of second class. That was 262. Female given second class. The only time that denominator was not for 46 was for a given style question. Given is the only time your denominator changes. That was 0.795. Female and style questions is where they meet. That was the 209. Or gives me more. I'm adding up all the spots in the table with female along with all the spots of second class. That gave me 74.0%. Are the events mutually exclusive for female and second class? Mutually exclusive means that there would be a 0 here for female in second class. It would mean it's impossible to have both of those values. So I would say no, because it's possible to have female in second class. That probability is not zero. Are the events independent? Oh, I'm glad I did this check earlier. Since the probability of female is different than the probability of female for second class, I would say the events are dependent. So I would say no, because my probability for female given second class is not the same thing as female overall. Let's check my results. Green's the whole way down. That's a good sign. This is looking pretty good. Let's try some more of these problems out together.